Hello everyone, my name is Thomas Kim. Today is May 10th, 2019. This is my 8th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn division by zero in floating-point arithmetic. More correctly, we will learn how to deal with floating-point arithmetic failure. For more information about floating-point standard, please double-click this link. This presentation clearly explains how floating-point numbers are represented in modern computer. Please read this documentation very carefully. It will be very useful and easy to understand. If a real number is of the following format, 1.0 or 1 times 1 over 2 plus 0 or 1 times 1 over 4 plus 0 or 1 times 1 over 8 times 2 to the power of n. If a real number can be represented in this format, then the real number can be accurately representable in floating point format. For example, 1.5 can be represented 1.1 over 2 is accurately representable in floating point format. Another example is 1.25. In this case, 1.1 over 4 is accurately representable in floating point format. But 1 over 3, this is 0, 3, is not accurately representable in floating point format. Informally, the real number can be defined like this: negative infinity, real number, positive infinity. In case of floating point number, negative infinity, valid floating point numbers plus infinity. Let's think about determinate states and indeterminate states. Determinate states minus infinity, valid floating point numbers, and positive infinity. Indeterminate states are infinity divided by infinity. The result is NaN, or not a number. Also, infinity minus infinity is NaN, not a number. But in determinate states, infinity plus infinity is infinity. So this is determinate state. This is indeterminate state. Indeterminate states. 0 divided by 0. The result is NaN, not a number. This is indeterminate state. But in this case, valid floating point number divided by 0 is either plus or minus infinity. So this is determinate state. Please compare this and this. For example, 5.0 divided by 0 is plus infinity. This is determinate state, whereas 0 divided by 0 is non-indeterminate state. In the floating point arithmetic, it does not matter whether it is divided by 0 or not. What really matters is if the result of the operation is in the determinate state or in the indeterminate state. Indeterminate state is invalid floating point arithmetic. Determinate state is valid floating point arithmetic. Then how can we detect indeterminate state? Before we learn about how to detect indeterminate states, let's learn about what is indeterminate states, some properties. NaN, or not a number, is indeterminate state. This is one property. The second property is NaN, indeterminate states, operator, and some operand is always NaN, indeterminate state. Also, some operand, operator, NaN is NaN, indeterminate state. Lastly, NaN is not equal to NaN. NaN, not a number, is not equal to not a number. So we can determine indeterminate state like this. Double D1 some value, double D2 some value, double RLT means result, D1 some operator, then D2 operator can be plus, minus, multiplication, division. If RLT is not equal to RLT, that is NaN is not equal to NaN, floating point arithmetic failed. Else, operation succeeded. Understanding this is the key of this episode. Now let's think about domain error. Domain error. For mathematical functions, there is valid domain range. For example, SQRT or square root dx should be 0 or greater. If x is less than 0, the return value is in indeterminate state. That is double RLT, SQRT minus 1.0. The value of RLT is NaN. Do not concern yourself about domain error. Instead, examine the return value from the function, from the math functions. So, math error no. You do not need to concern about these things. Math error no, math error except you don't need to concern. You don't need to concern about domain error. You don't need to concern range error. You don't need to concern overflow. You don't need to concern invalid. You don't need to concern divide by 0. You don't need to concern overflow. You don't need to concern underflow. No. Don't pay attention to these things. I click overflow. Don't concern yourself about these things when you deal with floating point numbers. Instead, concern yourself with indeterminate state. Once again, do not concern yourself about domain error or overflow or underflow. Instead, check the result is valid or not a number or not. To follow this episode, you have to watch my previous video, because this episode continues from my previous episode. You probably have to watch this video. Also, you probably have to watch from this video. You have to watch this video too, and also you have to make some settings. Beast extension, talkplayfun.com website, download latest code. Even if you downloaded it before, download it again. And if you haven't set system environment variables, please watch this video and make appropriate system environment variable settings. Otherwise, you cannot follow this episode. Without further ado, let's get started. Start your Visual Studio Code. In the CPP Extension folder, in subfolder tutorial, select tutorial, Then click this button, 008 real CPP. Control B, include talk platform output HPP. Include talk platform safe type HPP. Void examine integer float difference. int main. I copy this function name and paste. If you have this squiggle, then Ctrl Shift P, edit, configuration JSON, click this button. Then here you have to put dollar curly brace CPP extension dir. Then do like this. Then save all. Then you can close it. Then the squiggle goes away. In the global scope, talk platform, SS stream, auto, end line, talk platform, and there. Here, in case of integral types such as character, int, short, long, etc., etc., division by 0 crashes your application or your program. Now let's try it. int A 5, int B 0. So auto R1 A divided by B, it causes your application to crash. So stream mi crashed, and if your application crashed, this message won't get displayed. If it is not crashed, then it will be crashed. Wow, not crashed. I will modify like this. Start your command prompt. Sorry. Close it. Open your File Explorer. Move to the folder, extension, tutorial. Copy the folder path. Copy. Right click your command prompt. Right click once again. Properties. Start in Ctrl A, Ctrl V. Apply. OK. Now start your command prompt once again. dir 008. We have one file 008 real. We will be using clang std C++17 or 2a 008 real CPP. Okay, it built successfully. Voila, it crashed. Okay, we cannot see this message. 1. Now it should work properly. Okay, wow, not crashed. Now another thing, in case of floating point types such as float, double or long double, division by 0 is valid or invalid. Now let's try it. Double D1 5.0, double D2 0.0, auto R2 D1 divided by D2. Is it valid operation? Yes. Stream. Wow. Floating point division by 0. RLT is infinity. Okay, it should be infinity. R2. Okay, now let's try this. Wow. Floating point division by zero are to infinity, INF. Okay, it is a valid operation. If you want to test the result is infinity or not, then you can do this. Context here, INF infinity, we will say STD, numeric limits, double max. Okay, then here infinity, y is squiggle, say auto. Then we can test like this. If R2 equal to infinity, stream result is infinity. Else stream result is not infinity. And there. Now let's build and run once again. We are using GNU Compiler. Okay, result is not infinity. Sorry, I made a mistake. It should be result is not infinity. It is wrong. I probably have to do like this. Infinity. Then here we have to say double. Or we can just use this macro, infinity macro. Instead of doing this, infinity. This macro is defined include C float. This infinity is defined in C float in this header file. Now let's run it. Why? Infinity. Infinity. Probably I may have to include CMAS. Include CMAS. Let's try once again. Okay, it seems to be working. Result is infinity. Okay, I don't think I need this C float. I will delete this. Now let's try with GNU Compiler. Okay, GNU Compiler is also happy. GNU Compiler also works. Okay. Now if we provide it, for example, 1, this is not infinity. No, it is not infinity. So it's working properly. Okay. So in case of integral type such as int, character, short, long, etc., division by zero crashes your application. In case of floating point type such as float double or long double, division by zero is valid or invalid. Okay, valid means invalid. Infinity is valid state, determinate state. Invalid state is NaN. Okay, now let's test about NaN like this. Double D3 0.0 double D4 0.0. okay, auto R3 D3 divided D3 D4, this is 0 divided by 0. Okay, this is 0 divided by 0. We can test like this. If R3 is not R3, that is NaN is not NaN, operation failed. Stream indeterminate state, invalid floating point operation. End line. Here else stream determinate state. Okay, valid floating point operation, and there. Now compile once again. GNU Compiler CLS. So indeterminate state, invalid floating point operation, system does not crash. In case of floating point operation, your application does not crash. It works normally. Okay, so this is now indeterminate state. If we print out the value of n stream, the value of R3 is R3, and there, this is NaN. So the value is NaN. These are all valid operations. Now we will apply what we learned so far to our C++ programming. Namespace, types, talk play fun, types. Namespace, shape, talk play fun, shape type. I defined some namespace alias, template, type name type, types. This is return type. Enable if real number. We are enabling only when the type is real number. Shape, add type A, type B. Now we do our operation normally. RLT A plus B. If RLT is not a number, okay, then we can say talk play fun stream. We are creating local copy, or we can say OS. Okay, here OS floating point operation failed. A is the first argument. A, B equals B. Then talk play fun throw debug exception OS. So it means it failed. Then otherwise we can return RLT. So this is successful case. Now I copy this function. I copied, pasted, then it can be sub. This is subtraction. Then I can simply modify like this. Now I paste once again. This is multiplication. I simply change to multiplication. Now I paste it once again. Now this is division. Then I can simply change it into division. So everything works fine. Now here void example for shape floating point arithmetic. We have to use TryCatch block. TryCatch std exception E string E and L. We define some double D1 infinity double D2 negative infinity. So this is negative infinity. Now here auto RLT, I say R1 safe, add D1 D2. It will return infinity plus infinity is valid operation infinity. Okay, so string D1 plus D2 is R1. Now let's try it. If this message is correctly displayed, then this operation is valid. I will copy this function name, copied, pasted here. I will disable it. GNU Compiler. Let's try with Microsoft Compiler. CL EHSC STD C++ 17 or latest 008 real CPP FE AEXE. Okay, Microsoft Compiler compiles successfully. A. Debug file function A is infinity, B is infinity. This is minus minus. Okay, so it is done like this, so it fails. It is correct operation. Now we turn it this. Okay, we compile once again. Okay, it works successfully. Now let's say like this, double D3 is minus infinity. Will it be valid? I am not sure. Let's try like this. Then I copy this once again. Copied, pasted it here. It can be minus. I will copy this. Copied, pasted it here. Then it is 2. Okay, then it will be 3. It is effectively like this. So it is NaN, and it should be 3, and it should be 2. So we are expecting error message. Okay, now let's try once again. Okay, it works perfectly. This message comes from here, and this message comes from here. It throws. Okay, so plus infinity, minus infinity, they are added together, it fails. So instead of doing this, I will say sub. It is 2 minus, this is the same. Okay, 2. Yes, it will fail. It should fail. Now let's think about this division. Double D4 is infinity. No, we will just put 0. Double D4 5, 0. Now let's try with this one first. 1 divided by 0. Okay, then I will copy this part. Copied, it should be div, division, div, and it is R3. So 1 divided by 0, it is like 1.0 divided by 0.0. It should be infinity. This should be infinity. Okay, so it should be D4, D5, and this is R3. Now let's build and run. Okay, so this mess is 97. No. It is coming from this message, not here. So I will make it work by introducing 3. Okay, then this line will work because this is minus minus, it will work. It becomes like this, minus. Then it is infinity. Now we can understand this part. So why this is correct? Why it throws? It is division. Div. What's the problem? 4, 5. Sorry, we have to provide 4, 5 here. 4, 5. Okay, I fixed. Then it should work. Okay, this is infinity. Now let's try with GNU Compiler. This is GNU Compiler. GNU Compiler works successfully. Now Clang works successfully. All works successfully. So this mechanism, understanding this mechanism, you probably need to understand the mathematical background first. So in high school mathematics, we learned the concept of infinity. Before we learn calculus, we learn sequence and series. When we learn sequence and series, we learn the concept of limit. When we learn the concept of limit in our high school mathematics, we learn when infinity is added with another infinity, the result is infinity. This is determinate state in our case. But in case of infinity over infinity, infinity is divided by infinity. This state is not determined. Also, infinity is subtracted by another infinity. The result is also indeterminate. Also, 0 is divided by 0. This is not actually 0. It is limit to 0. Okay, it is something like this. LIM, x approaches 0. I will put another line here. X approaches 0. X over x, or 2 times x. Okay, in this case this is 0. X, this part approaches to 0 and this part approaches to 0. In this case the value is of course 2, but in floating point arithmetic, 0 over 0 cannot be determined, so it returns indeterminate state or not a value. This case is also indeterminate case, but in this case it is determinate. Infinity is returned. Understanding mathematical background is really important. And the floating point numbers in modern computer is modeled after mathematical theory behind. I hope you understand. In future, I'm planning to create a new series for numerical analysis using C++ language, because understanding numerical analysis is really important if you want to create or implement more advanced programs such as neural network or artificial intelligence. All these things, if you want to implement, basically you need numerical analysis. Please subscribe to my YouTube channel. Thank you for watching.